All right. Hello? Hello? Okay, you guys ready? Okay, so right here, 7.6. So trap rule with empirical data. Yes, I worked really hard at saying that one correctly. Okay, so now doing the trap rule, we're now going to be given a table, and with that table, we're not going to have a uniform delta x. Does that make sense? So there's not a uniform delta x. So we're going to actually try and use this to go, you know, in for whatever we have. So now let's take a look. And it says the diameter of each cross-section cut measured is the area A recorded in the table below. X is the distance in feet of the cut of the top of the trunk. Find the approximate volume of the trunk. Okay, so area, right? So think of this. It's area, but it's tall. It's area with time, with the depth. So it's kind of like saying I have a circle right here. See this circle? And I gave it height, and so now it has volume. Yeah. So if I have an area that I give height, it gives me volume. So now it goes from 2D to 3D and 4D. In four-dimensional time, this was once full, and I had coffee. Anyway, all right. So, okay, so we're going to go ahead and do this. So we're doing this. So let's go ahead. So right here, recorded, find approximate volume of. So let's go ahead right here. What is my delta x here? It's going to be 20, right? Yeah. Okay, so I'm going to have 20 is my delta x, right? So it's going to be 20 times, okay? Remember, that was the height. When we talked about the trap rule, the x, the delta x is the height, right? And it should be, what else am I missing here? 1/2, right? So it's 1/2. So it's going to be over 2. And then it's always going to, and it's going to be B1 plus B2, right? So that was my two heights of my trapezoid. So it should be, in this case, it's going to be here, right? So that's going to give me 120 plus 124. Yes? Yeah. So there's that. And now let's do the next one. So plus 20 over 2, right? Times my 128 plus 130. That's 20 from here to here, right? Plus 20 over 2. And that's going to be, oh crap. Yes. I just noticed that. Thank you. I know, right? So sorry, all those YouTube people over in Holland that are, upset with me right now. I'm sorry. Okay. I got one view from Holland the other day, and I was like, oh, yay. All right. So 124 plus 128. All right. Plus 20 over 2. Plus 130. Okay. Plus, all right. There we go. So yeah, you like that? Okay. So, and so on. Okay, so for that, are all of these going to be uniform? Are they uniform? There's 20. That's 20. 20. 20. But that doesn't matter. So if they all are uniform distance apart, what can I do with my delta x there? I can factor it all out, right? Because it's all going to be 20 over 2, isn't it? Yeah. Okay. So if it's all uniform now, I can take that out. So let's take it out and let's call it 10. Hey, okay, I'm just land of make-believe. This is going to, 10. So this is 10. And since they are uniform, what is my function going to look like if I'm going to use the function that we made the other day? How many times do I use the first value?
Once.
Okay, so it's going to be 120 plus how mmany times do I use the last value? Once. That one's also once, right? So it's going to be, no, that's 158. Plus, now, how many times do I use all these other ones here in between? I use them twice. That's why I made circles in between each one. So to show that I'm using it twice, so 2 times, okay, so let's start doing my value. So it's 124 plus 128 plus 130 plus 132 plus 136 plus 144. There we go. Yes?
Yep.
This is not bad. It's just a whole bunch in algebra now, right?
Yep.
So it's algebra masquerading like calculus. So you just have to be able to do some math together. All right, go ahead and do that, please. You have this thing. It's called a handy dandy calculator. What's up? Oh, I need to give her one, right? $18,660.
18,660.
One more time, please. 18,000.
And is this volume?
Yeah.
So it's going to be feet cubed, right? Okay. Is that pretty easy now? So I could actually do the math every single time for every single trapezoid in between there. Or I could try and shorten it a little bit.
Wait, 3 miles of tree?
It's volume.
I know.
It's volume.
I know. It's just funny. 3 miles cubed. I mean, not really, but.
No, it's
I
not.
know.
Do you?
Yes.
Do you know?
Yes.
Do you want me to convert this into miles?
No.
Yes.
Okay, because you would.
No.
For the conversion, it's this and. Crap. Okay, so do you know what? No, just because. You know, do you want to do the math on it? Let's do the math on it.
Yeah.
So it's 18660 feet cubed,
Yeah, be the funny guy, huh?
right?
Yeah.
I don't want feet anymore, right?
No,
Right.
4 miles.
So I have to put feet where to cancel it out?
On the bottom.
On the bottom. So feet,
Feet cube.
okay, feet cubed. But I'll show you guys how this is fixed. So, funny guys, oh my goodness. Okay, so you guys, you know what? I hope you have to do this on AP test. Feet here, okay? So, but I have to cancel out 3 of them, don't I? Because it's feet cubed. It is a 3-dimensional. And I know the conversion of a linear, right? Conversion of a linear, so now I need to have feet and feet, right?
So it's 5,280 cubed.
Okay, so now it is to miles, go there, right? Okay, miles there, miles there. So it's going to be 1 mile is 5,280 feet. So it's actually 5,280 cubed.
That's a much smaller than.
Yes, it is much smaller. Very, very, very small. So, is that a mile?
A mile cubed.
Okay. And so when I'm done, because my feet will cancel, I will have mile, 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 so that's going to be cubic miles, right?
Yes.
Okay, cubic miles. You would do the same thing if you're actually converting areas too. If I was doing areas, I would only do that twice, right? Because areas, they two-dimensional.
Yep.
Make sense?
Yes. Yeah.
Okay, foreign kid.
Yeah.
Okay, I know you don't like miles, so that's why. So if I was to say kilometers, okay, it's kilometers.
Kilometers.
So I had this girl from I don't know, like some foreign country in here yesterday, and she's like, what is this feet? What is this feet thing? I'm like, it's like a decameter. Oh, okay, I get it. Or yeah. So anyway, all right. Simpsons Rule. What did I say about Simpsons Rule? Don't do it. Yeah. All right. So approximating displacement using trapezoidal sums. Approximating displacement using trapezoidal sums. Okay, velocity v is in meters per second of an object in rectilinear motion is measured at times t, shown in the table below. Now, approximate the net displacement. Net displacement. So what does net displacement mean? Okay, so I just got done having a good speech last hour. Okay, I am here. I'm walking to Douche Bros. It is 1 mile. Okay? So, I walk from here to there, that is 1 mile. So, my velocity is going forward, isn't it? Mm-hmm. Now, I'm going to walk backwards from Douche Bros all the way back to here. I'm going to walk backwards. So, if I'm walking backwards, isn't that a negative velocity?
Yes.
If I'm walking, okay, so now, what is my net displacement if I end right here? 0. So net displacement is going to be 0 because I started here, I went there, and I came back. So I'm adding the positive and negative together. So my net displacement is going to be the sum of those, right? But what if I'm asking for the total displacement? That's the absolute value, right? It had to be absolute value of the velocity. So I'm going to actually get forward and backwards. So it's going to be a positive forward, and that means I have to walk forward going this way, right? Okay, so I'm not going to walk backwards. Anyway, so it's there to there, so it'd be 2 miles is my total displacement, where my net displacement would be 0. Yes? Okay, good. All right. So let's see. Approximate the displacement here of the object 1 to 10 using trapezoidal sums. Now, is the delta x uniform?
No.
In this case, it's delta t, right? Is it uniform? Look at here to here. 1. Okay, so it's not uniform. So on that previous problem, it was uniform, so I could factor that out to make this easier, right? But because it's not uniform, I have to do each piece individually. Okay, each trapezoid individually. So my trapezoid from here to here, that's going to give me my delta x, which is going to be 1, right? So it's going to be 1 over what? 2, thank you. Man. All right, and it's going to be, what are my values? 4 plus 7. Right?
Yep.
Plus 4 plus 7. The delta x, because from here to here, the height is 1, right? It's the regular formula is 1/2 h b1 plus b2. This is the algebra formula, or the geometry type formula. So where my delta x is the height, because my trapezoids are actually going up and down, they're not on top of each other, right? So the parallel sides are b1 and b2. So this is my delta x times my 1/2, and then b1 plus b2. So that's these two values. This is my f of x, f of b1, and f of b2. Okay? All right, plus, what's my next one? What is my next delta x? 2 over 2 times 7 plus negative 2 plus, what's my next one? 4 over 2 of
Negative 2 plus 0.
and my last one.
2 over 2.
And that's going to be,
0 plus 4.
come on, my pen's running out of ink again. There we go. So let me see, that's 11 and times 2, 5.5. And this is going to be plus 5. And that's going to be negative 2 times 2 is minus 4. And then this is going to be 1 times 3. So add those all together, and it's going to be, let me see, 3.5 minus
9.5.
9.5?
Yep.
Okay.
We can do addition.
So, what are my units?
Addition
Yeah.
Meters. Okay? Since we're talking about a velocity in meters and it's rectilinear motion, so we're asking how far it went in a direction. The motion is going to be just meters.
And if we said approximate the total displacement, that negative 4 would be absolute, or what?
Yes. So from there to there, I would actually get an absolute value for that.
Yeah.
Okay? So that would be basically, but we're not going to do that for like a trapezoid, right? So, you know, I don't think I've ever seen someone, yes, I could.
You could say it. But
Yeah, I could say it. Be like, oh yes, approximate the total distance traveled, okay, for that, and anyway. But yes, anyway, are we good?
Yep.
Super. All right, so Simpsons Rule. Don't do it. Don't do it. Don't do it. Don't do it.
Error.
Don't do it. Don't do it. Hey, look, we're done. Okay, so Simpsons Rule is not an A, B, or BC topic.